Did we get to the end of chapter 2? Real close to it. Yeah, this is looking all real familiar. We know what a binary operator is. It's one that requires two operands. Operands being the pieces of data it works on. So something slightly more subtle that I want to mention is that if you have an expression like this, A plus B divided by C times D, that's got a bunch of binary operators in it. And it looks like it has more than two operands. Well, each symbol has two operands, but the operand may be the result of a prior calculation. So what happens first? Stuff inside parentheses happens first. So we got to do the division first. The division is the operator. Why don't we really fill in numbers here? Right, just that's a 10, that's a 4, that's a 2, and that's a 3. Okay, so the first thing that happens is a 4 divided by 2. That gets evaluated to a 2. So that one was handled. I'm going to do some copying and pasting. I don't really expect y'all to type along with all these. Okay, so that got replaced with that. Now what do we do next? Does addition happen before multiplication? Multiplication happens first. So that's got to happen first. And there's two operands for that. So 2 times 3 turns into 6. Right, since 2 times 3 is 6, that gets replaced with 6. Now there's only one operator left. Not true. That's another operator. But we got to do the addition first. So 10 plus 16 is, 10 plus 6 is 16. And then A is equal to 16 at that point. We have one operator left, the assignment operator, which just copies the value of 16 into A. And then so now we finally have the value of 16 in A. So at each point, the operator only had one operand. And I do recall now that we got up to the ternary operator. I don't think we got a lot past that. I think, let's see in our notes. Yeah, we got to the ternary operator, and then it looked like we started doing some integer division down here at the bottom. So, just as a reminder, I'm pretty sure I demonstrated it. If both numbers are in integers, the answer is an integer and then rounded down. It doesn't matter if you have a double over here, the most precise data type available to us. D at this point is still going to equal 2 because everything on the left-hand side happens first before it gets copied into there. The compiler doesn't go, oh, by the way, we're going to be storing into a double, so we may as well do this math a little bit differently. No, the math happens no matter what, and then it gets copied across the equal sign and stored over here. So at this point, D would equal 2 because these are both integers. Howsoever, if one of them is floating point or the other is floating point or they're both floating point, it does not do integer math, meaning it does not round down. So if we did double D, and we should not be capitalizing the D, should we, is equal to 13 divided by 5.0, then that 2.6 would get assigned into D. And the modulus operator. Did we talk about modulus? Good. Comments. We've already been using comments the whole time. They're ignored by the compiler. Used to document parts of the program. They're just for the person reading the source code, to put comments there that, things that you need to remember about it or that somebody else needs to know about it. What's the purpose of the program? What do the variables mean? The various sections of the code. There are single line comments, // that's the equivalent of the hash if you took Python. And then there are multi-line comments. This was the original style of comment. Back when C was invented, there was not single-line comments. But it was really annoying to have to surround everything by star slash slash star. So, somebody invented single-line comments, and it became part of the standard. You just start your comment block off with a slash star, and then you end it with a star slash. But you can use it as a single-line comment if you want. Named constants. Named constant is a constant that's got a name. Python did not have the const keyword, so there was no way to make a constant. So if you took fundamentals of logic, then you faked it just by using uppercase names. And you kind of signed a gentleman's agreement with yourself that your program would not change that value once assigned. Well, we have this keyword in C and C++, so we don't need to make that agreement. It's just a fact. The fact that once tax rate is assigned that, nowhere else in the code can change it. That's just to stop you from making a mistake. It's not like it makes the program safe from hacking or anything like that. It just makes it that you're not going to make a mistake. You're not going to change the tax rate later in the program. Maybe when you're writing your code and you're 20 pages down from the top of the code and you saw the tax rate variable and you thought, okay, but if I do a lookup and I find out that Utah's tax rate is different, I can change this variable. No, you can't, because it was declared as a constant. Same with the number of states. People name them with uppercase letters just because that's the consensus. If everybody names them with uppercase letters, then anytime you see a variable with uppercase letters and an underscore, colloquially called snake case, that's silly, snake because of the underscore, then it's a constant. You use constants to hold what would otherwise be so-called magic numbers. If I had this line of code, A is equal to 32 divided by 16.01 times 6.022 e to the 23. If you saw that line of code, or even if it said grams, right? Even if we had a clue as to what was going on here, we don't know what 16.01 is. And unless you're a chemistry student, you probably don't know what 6.022 e to the 23 is. Those are magic numbers. They're literals. They're literally coded into the program. They're unnamed constants. We don't know what they are. If we gave them names, though, const double atomic weight of carbon. I'm not sure that's the atomic weight of carbon, but let's pretend it is. And then const double Avogadro's number equals 6.022 e to the 23. Then, if we saw our equation, it'll look like this, AW underscore carbon times Avogadro's. Now, unless you've taken chemistry, you still don't have a clue what in the world is going on there, but you have a lot better chance of figuring it out, right? Because you could Google it. You could Google up what Avogadro's number means. And especially if we added some comments, right? Atomic weight of carbon. I know that's not right. It's 12. And then the atomic weight of, or atomic mass, I guess mass is the correct term. Instead this is Avogadro's number. Google it. Hit Wikipedia. You find out what that is. Right? This makes a lot more sense. And if it turned out that this wasn't a good enough value for Avogadro's, I would only have to fix it one place. Maybe my program was calculating the number of atoms in 27 different formulas. I might have copied and pasted that number 27 times, and I might have made a mistake in one. Or maybe it turned out that I needed to get a more precise value for it, and so I would need to do a search and replace in my code base for every occurrence. Well, if it was declared as a constant, I would just find it one time and fix it. What is the most precise version of Avogadro's number? Avogadro's number. I misspelled it. It's Avogadro's. Okay, here we go. Copy and paste that. Now my program is more accurate. just so that nobody makes fun of me. There we go. Okay, so that's the idea behind constants. Constant variables declare with the const keyword. If you use Java, it's a different keyword. It's a final keyword. Used to hold magic numbers, numbers whose values should not change and are not obvious in their meaning. What do I mean by that? If your equation is diameter is equal to 2 times pi times radius, yeah, the 2 is technically an unnamed constant, but you don't need to go and define a constant for 2, right? You don't need to do this. Const int diameter to ratio, radius ratio, right? That would be ridiculous. There's no reason to do that. The 2 is just part of a formula. It's a ratio. It's okay to leave it as 2. So you don't need to go nuts defining everything as a constant. But like upper limits, the number of items in the list you're going to be able to store, the number of elements in the array, the maximum value that you want the user to be able to type in, or the lowest value you want to be able to type in, things like that you could declare as constants. Would the program work just as well if they weren't declared as constants? Yeah, but if you're working in a large organization, you want to make your code as easy to maintain and as difficult for other people to make mistakes as possible. So by defining things as constants, then you're telling the other users, the other programmers, you better not change that unless you really know what you're doing. There could be severe consequences for changing them. Calculations may be wrong, the program may crash, whatever. Programming style, that's the visual organization of the source code. How you use your spaces, how you use your tabs, how you use your blank lines does not affect the syntax of the program, but it does affect the readability of the source code. So if I launch Visual Studio, and Zach, you're not really far behind, you'll catch up almost instantly. If I launch Visual Studio and I go and find one of these files, I could remove almost all the carriage returns except for the comments, and it would work just as well. I have too many comments in here, so I can't do what I'm trying to do, right? It would work just as well. Unlike in Python, where tabs mean something very important. Or if I had a bunch of blank space where I'm not supposed to, it still works just as well. If I don't line up my braces, it works just as well. But programming style dictates that you want to write code that's easy to read. So you're going to line your braces up. You're going to use good spacing. You're going to use white space. I had a student who hated white space, and so he just flat out refused to insert blank lines. Okay, whatever. Yeah, I gave him full credit, but everybody else on the planet who is a pro programmer likes using blank lines, just like putting a space between paragraphs when you're writing something. It makes it easier to follow along. So we may as well, since we know we're going to be typing in some code, we may as well start Visual Studio and get our lecture up and going. So we have some students. This is our first day. So I'm clicking on the magnifying glass. I'm going to launch my app, Visual Studio 2017. And I'm going to make myself a new lecture. File, new project. And out of all the projects you want the one that says C++, empty project. And let's give it a good name. I'm going to call this one CPP_lecture D. You can just call it lecture D because you're not taking my other C programming class. That's how I'm distinguishing the two. You don't care. But I want to make sure it's not in this stupid directory. It's defaulting to a stupid directory. Users, JG, Thompson, source, repos. And I know the rest of y'all have heard this lecture. On your laptop, it may be saving to the documents directory, which is great. But mine isn't. So I'm going to click Browse. Documents, because that's where I would prefer for it to be stored. And maybe even inside the Visual Studio directory, but this is good enough. Just get it out of that repos, root directory kind of thing. And then kind of take note of that so that you know where you can upload it when you finally need to upload it. Now we're going to need to add a new C file. So I need my Solution Explorer over to the side. I don't have a Solution Explorer there. If you don't, it's because you closed it, just like I did. Choose Solution Explorer, right-click on Source, Add, New Item. We want a CPP file. Since this is the 4th lecture, let's just call it Lecture D. And now we need all of our stuff, our int, main, and stuff like that. Now, since I know the students are just here for the first day, do not have the boilerplate ready. One more time, I'm going to type it in by hand, but I want you to do a save. I want you to copy and paste it into a boilerplate file from then on. Those of y'all who have boilerplate, go ahead and use it. So the first line needs to be #include less than IOStream greater than. That brings in that header file, just like the import statement in Python. #include CMath end angle, just always we want to include that. And #include angle string, close angle. Then one more line using namespace std, semicolon. And while we're on the topic, we'll go ahead and talk about what that means. Now we need to declare our main method, int space main, parentheses, in parentheses. Hit the enter key. Curly brace, shift of the square brace next to the P key. We're going to see out something, see out quote lecture D \n end quote semicolon. Or better yet, I'm going to take the \n out just because I'm going to be proving a point later. So lecture D end quote arrow arrow ENDL. Okay. And then a pause command if you're doing this on Windows Visual Studio. If you're a Mac user, leave this out. If you're a Linux user using Cygwin or something, system quote pause end quote in parentheses. That's our boilerplate. You're going to want to open that. You're going to want to copy that into a notepad file and save it to your desktop or something.
Don't forget to return 0.
Oh, thank you. You saved me. Okay. It would run without it, but it's incorrect. There we go. Return 0. That's our last line. Okay, so I'm going to highlight all that, copy it, open up Notepad, magnifying glass, Notepad, paste it, save as, put it in your programming directory, boilerplate, _cpp.txt. I ought to just upload that. Okay. Alrighty, now when I run it, it should just print lecture D and pause. That's my goal. Lecture D. Cool. We're going to spend just a little bit of time playing with the editor. And if you're not using Visual Studio, then you're just going to get to watch and know that these concepts apply to Xcode or whatever as well. And then you're going to have to find a tutorial or something that shows you how to do it on Xcode. Just watch for a moment if you're not doing Visual Studio. Say I have a variable, int x equals 3. And then later on, I ask the user to type in a value of x. Or, see out, arrow, arrow, less than, when I say arrow, arrow, quote, enter a new value for x, colon, end quote, semicolon. And in cin, arrow, arrow, x, the arrows go the other way, because it's input, so the arrows are going towards the x. And now let's square x. Or let's cube it. X equals POW, parentheses, x comma 3. Raise it to the 3rd power. Now what's POW? Python came with all sorts of built-in functions. There aren't any built-in functions into C. But Microsoft added a whole bunch of stuff and said that they were built-in functions. I won't say that they added it. They took functions that are commonly used and they made them built-in. But on the Mac or on Cygwin or something like that, you're going to have to do # include CMath in order to get the POW function. So that's why we put it up there. We're not writing Microsoft-specific code. We're just trying to learn how to do C++ in general. Okay, and then let's write out X. Cout error arrow, quote, X equals space, end quote, error error X, error error ENDL. So we have some code here. We're going to do a couple things with it. One is we're going to talk about what that using namespace command does. Why we like it. And then I'm going to tell you that if we were a professional programmer, we would probably leave it out. Or if you were going to post your code to the internet for somebody else to see, you'd probably leave it out. It's considered poor taste, but it's so useful. Enter a new value for X. Okay, 67, and X cubed is equal to 300,000, whatever. Why don't we actually put that in our print statement? For one thing, we don't need it to say enter a new value of X. I'm going to delete that word new just because I don't like it. Enter a value for X. And then I'm going to say X cubed equals. All right, enter a value for X, 10. X cubed is 1,000. That is correct. What does that using namespace mean? Make sure everybody's got this running without syntax errors. Take out that using namespace command and watch what happens. When I say take it out, don't delete it. Just put a / in front of it. Comment it out. And oh boy, all of a sudden, we have all these red underlines telling us there are errors. We can fix that. If we did std : there, and we did that everywhere there was an error, std : there, doesn't look like it's fixing it, but when I hit Control S to save it, it indicates that they are fixed. std : std : oops, I've still got some, almost done, there. It's a pain to have to type std : in front of everything, right? It doubles, more than doubles the amount of typing, right? 5 extra characters for each one of these. So what does using namespace do? It says, if you can't find something, Mr. Compiler, check to see if you could find it if you had prefixed it with std : And yeah, it can. Well, all of these are located inside the IOStream header file. So it's kind of funny that you don't say using namespace IOStream or something like that, but I didn't pick the language. Inside the IOStream library, a bunch of them are marked off as being standard functions. But you might need to use the word cout for some other purpose, or ENDL for some other purpose. And if you were using the word ENDL for some other purpose, and then you put # include IOStream in there and using namespace, then you have a naming conflict. So that's what you use namespaces for, is to create things, and then you have the option of whether you're going to put std : or whatever your namespace is called or not, based on whether you have that using on there. Kind of like if you're at the Thompson family reunion and you're pretty sure that everybody in there is named Thompson. So, using namespace Thompson, and if I walk up to you, I can say, hey, Bob Thompson, I'm glad to meet you. And eventually I'm going to meet somebody whose last name is not Thompson, right? So maybe I should not have assumed that everybody is named Thompson. Maybe I should not have used namespace Thompson at that family reunion. Maybe I should, actually let people write their last names on their name tags or something like that. So from now on, I am going to be doing that. I don't have to change my code back. I kind of should because it's kind of cluttered, but I'm not done. I'm not going to make y'all do the typing. Let's give one more example of namespacing. Let's say I want to create a constant called pi. So I'm going to do namespace my math, hit enter, curly brace, const double pi is equal to 3.14159 colon. And let's say I wanted to use that for some reason. Double area equals pi r squared. So pi times, we don't have an r, but let's pretend that the circle's got a radius of 10. Or POW, 10 to the power of 2, right? All right, it's underlining pi. It says pi is not defined. That's because it's in a namespace. If I go and put my math colon colon in front of that pi variable, it's going to start working. My math colon colon pi. That fixes the error. You can cordon off your variables that you put up at the top of your program, surround them in a namespace to prevent them from conflicting with the variable names that other people may want to use, or the function names that other people may want to use. Now, honestly, I'm not going to be throwing a lot of namespaces into our code here, but we sure are going to be using that using namespace thing a lot, so I wanted you to understand what it was. Well, what if I really hate the idea of typing my math colon? What if I had to use the variable pi 8 billion times in my code? Okay, that's unlikely. But I typed it in 32 times. That would be annoying. If I want to not have to prefix it, I could do using namespace my math, semicolon. And then double x equals pi, semicolon. I did not have to put my math colon colon in front of it. So that's what the using statement does. It makes those variables necessary without using the namespace colon colon syntax. Pi is declared inside a namespace. I cannot access it unless I A, use the prefix, or B, have that using statement. Did I break anybody's code? Anybody have syntax errors? Boy, I sure broke my code. Oh, that's because I redefined x, right? I have x defined in 2 places. Okay, fine, I'm just going to delete one. Delete the second occurrence of x. And it runs again. Okay, great. And we are at the end of the chapter. So onward and upward. Did we work on the chapter 2 quiz together in class? No? Well, we're going to do that. We're going to take the chapter 2 quiz together. Not because I don't want y'all to learn this stuff yourself, but just to make absolutely sure we know how to handle the quizzes. Make sure it looks good. I've never taken a quiz before in Canvas. It's possible that it's your first time as well. But let's make sure that the quiz even shows up. Quiz, chapter 2 review, there it is. If you've already taken it, well, I haven't graded it yet, but if you've already taken it, you can just watch, or you can take it again while we do it together. I need to slip into student mode so I see exactly what you're seeing. And since I'm essentially going to be giving y'all the answers or asking you for the answers, that means that the learning experience is not going to be quite as good as it would be if you had to struggle with it yourself. So take the quiz a second time. just to make sure you got it. Okay, so I'm going to go to quizzes, and you don't have to do this, but why not, huh? Quiz chapter 2. Take the quiz. Notice allowed attempts unlimited. Right? So if you don't make 100 or you don't make a 90 or whatever your target grade is, you can take it again. Alrighty. This is an open book quiz. You can use your book, your notes, the PowerPoints, or search on Google for help. Wow, that's nice of me to say you can use Google. However, don't use Visual Studio or Xcode to figure out the answers. If there's something in there that involves math, do it in your head or on pencil and paper. Don't just go open up Visual Studio and print out the results of, 2 modulus 3 or something like that. You don't learn anything from doing that. Do the quiz yourself. Don't ask for help from someone else except me. Click true. But we're going to do this one all together. So yeah, we're still going to click true. Now I had some smart aleck click false on the do you agree to these rules question. And then I had to give him a 0, and I said, why did you choose that? He said, I was just joking. Yeah, I had to take it again. Okay, which of these are legal variable names? Are they randomized on yours, or is tax rate 2016 the first on yours as well?
They're random.
All right. Well, anyways, this tax rate 2016, just eyeball these and tell me one that you spot as being illegal. Somebody tell me one that's illegal. That one's bad, so I'm not going to select that one. How about tax rate 2016? Is that good?
Yes.
Yeah. How about tax rate percent? No, because it's got a special character. The only special character allowed is the underscore. Tax rate, that one's bad because it's got a space. Underscores are okay. How about that one? Bad because it starts with a digit. Variables can only start with underscores or letters, but not digits. And that one's okay. So it looks like 3 were right and 3 were wrong. How many operands does a binary operator require? I don't know why I say just select one answer when I think you're only allowed to select one. But I imported these from D2L, and maybe there's some quirks involved. How many operands are on a binary operator? What does binary operator mean? If you have A is equal to 2 times 3, that's the operator. How many operands does it have? 2. Right. Binary operator equals 2 operands. Almost everything we use is a binary operator. The only exception is the minus sign, because if you say A is equal to minus 3, the minus flips that 3 and makes it negative. We don't think of this. We think of a minus sign as being part of the number. But there is no minus digit, right? If you were going to count out on your fingers, you could go 1, 2, 3, 4, 5, 6, 7, 8, 9, and you would never find a minus sign. There is no minus digit. It's an operator that flips the value of it. So a binary operator is 2 operands. Not operands. Operands. Now I can't spell. There we go. Assume you have the following declarations. A equals 0, B equals 0, and C is equal to 0. Write an assignment statement that does the following. Store the value 10 into C. Please leave all spaces out to help the autograder. All right, when I say leave out all spaces to help the autograder, that's just because if you typed in this, by the way, this is the answer, C equals 10. If you type that in, the autograder is going to count it wrong. Now, does that mean you got it wrong? No, but I have to grade all these by hand to catch all the mistakes the autograder makes. If you took the spaces out as requested, the autograder is not going to count it wrong. It saves my time. So, store the value of 10 into C. That is, in fact, how you do it. C is equal to 10 semicolon. Alrighty, same business. A is equal to 0, B is equal to 0, Z is equal to 0. Store the value of A plus 10 into B. Well, what's the variable name that's going to go on the left-hand side? B equals. Now, what else do I put here? How do I finish this off? Yep, A addition symbol plus symbol 10 semicolon. Oh, and by the way, guys, even though I've asked for no spaces in these answers, if it looks like it's going to be flat out wrong because you left out the spaces, go ahead and put them back in there. And I'll give you an example. What if the answer to this was using namespace std, semicolon? Now, if that's the answer, I'm not going to put no spaces in your answer. But if some chance I did put that in there, what I would probably say is no unnecessary spaces in your answer. Well, what would an unnecessary space be? Write that or something like that. These are necessary spaces. Is that a valid command? Using namespace std. No, that's not a valid command. Some people will go, okay, well, I guess I'll use underscore since I'm not supposed to use spaces. Yeah, I'm going to give you credit for that, but the auto grader is going to hate it. So, all right, let's get me back to the right answer. B equals A plus 10 semicolon. Question C. Multiply 3.14 times B and store into C. So what's the first thing in my equation going to be? C equals, what next? This is easy. I could copy and paste, except I need to take the spaces out. 3.14 times B. Or I could use the POW function, but I didn't ask you to. I wouldn't count you wrong if you used it. That'd be pretty awesome. Autograder count it wrong, but I'd be impressed. So, you know, of course you're going to get the points. Who cares what the autograder does? It's just to speed things up. Assuming you have the following declarations. Character C. Write an assignment that stores the character K into C. Now I'm going to type in the wrong answer, and I want somebody to tell me what's wrong with it. C is equal to double quote K semicolon. I swear on the exam, at least one person's going to type that in. Because why? Because we're used to using double quotes everywhere. What do you use for characters? Single quotes, just like that. You got to use apostrophes. I even tell you that there. It's not meant to be a trick question, but you just got to know that if it's a character data type, you got to put single quotes. I know it didn't matter in Python. It does matter in this language. Assuming you have the following declarations. Int b equals 100. Write a statement that does the following. Subtract 1 from b and store the answer in b. Now there's way more than one way to do this. I'll give you some ways. How to subtract 1. Not dubtract. It sounds like dubstep. How to subtract 1 from a variable. There's a fancy name for that. Decrement. If you're adding 1, it's called increment. A minus minus semicolon subtracts 1 from A. A minus equals 1 semicolon subtracts 1 from A. That's probably how you did it in Python, unless you did it like this. A equals A minus 1. And maybe you could cook up another way, but those are the 3 standard ways of removing 1 from a number, right? So you can pick which one you like. I just settle on that one. If you're a hardcore Python programmer and you can't get over using minus equals 1, and then go for that. If you feel like spelling it all the way out because you were like writing it in pseudocode style, feel free to do that. But I'm going to use minus minus, except it wasn't A minus minus, it's B minus minus. Oh, and by the way, just because I let y'all use your notes during exams, I don't know how to phrase this exactly. If you think that copying out of the notes and pasting for your answers is gonna get you the answer, it's not gonna always do that, right? What if the question was worded like this? You know, write an expression that calculates the rate. You don't have to type this. This is just a warning, an example. Calculates the area of a circle and stores it into a variable named A. The radius variable is called R. Okay, that was the test question. Assume the variables are already all defined, declared and defined. Let's do it. This is easy, huh? If you understand it, it's easy. Well, if you might have to Google the area of a circle formula, or maybe I'd give it to you. A is equal to pi r squared. So, I wouldn't, that might work, or 3.14159 might work. Maybe I said use pi as your variable, as your pi variable name, right? So pi times r squared. So maybe we put r times r, or maybe we use a POW function. That would be a full credit question, right? What if you didn't know that, and so you thought, okay, I'm going to go through my notes. I'm going to find something that uses area, and so I'm going to take this code. Oh, maybe I want that too. I'm going to go and paste it. There. All right, that's my test answer. Is that a full credit answer? Does that answer the question? No. And I'm not trying to be silly, but I swear people think that if they don't know the answer, they can go in the notes and they can copy and paste. Yeah, that might work for a definition, right? What is the definition of a class? And yeah, maybe I've said what a class is, and if you copy and paste it, and if I didn't put the magic words in your own words, what is it? Right? If I don't say that, right? Sometimes copy and pasting will work, but you need to understand it. And so if you're just taking snippets of code and copying and pasting it, hoping that the snippet is closely enough related that you're going to get credit, I don't think you're going to get a lot of credit for it. Okay, so sorry for that digression. B minus minus. Now, if you copied and pasted, you might also put B equals B minus 1 semicolon B minus equals 1. And if you felt like listing all three of those, I wouldn't count them wrong, right? Very, very thorough answer. You don't have to do that. I just asked for one. All right, which keyword or escape sequence causes the printing to go to a new line? Now, these are randomized, and I kind of wish they weren't, because both will work, should be at the bottom. But, okay.
So what mine did is it made me choose all three.
All right. No, that wasn't my goal, and when I grade it, I'll have to check to correct that. But forewarned is forearmed. Is this valid? Standard colon colon C out arrow arrow standard colon ENDL. If we left off the STD colon, that would look real obvious. C out arrow arrow ENDL. Yeah, that's valid. Both will work. That's true, because using quote \n is also valid. Write a line of code that will print my name is Bob Roberts. Okay, here's a 0 credit answer. C out arrow arrow quote, my name is Bob Roberts. Maybe you remember the semicolon. Why is that wrong? Because this top line of the question, using the following variable declarations. We have two variables named fname and lname. So your answer better include fname and lname. And I'm not trying to be pedantic. I'm giving examples that at least 10% of every class miss on the exam. So we're going to do C out arrow arrow fname arrow arrow lname arrow arrow ENDL. Now, is this the right answer? By the way, I wish it gave us more space to type there. But is that the right answer? No, because what did it skip? It didn't print out the words my name is. All right, let's keep going. C out arrow arrow quote my name is space end quote arrow arrow fname arrow arrow lname. Is that the right answer? We're almost there though. What's missing? I think I heard somebody say it. Yeah, the space. So between fname and lname, there should be a arrow arrow quote space quote arrow arrow like that. Now I'm going to copy and paste that into Notepad just because it's hard for y'all to read what I've got. But that would be the correct answer. And I said I don't care if you include spaces or not. So if you feel like fluffing it up like that. There. Maybe I need to change that. I don't care if you include spaces or not. Did I word that more carefully? Oh, you can use STD or leave them out. I didn't mention spaces. Okay. So just like I said, you know, the pros would probably go ahead and put STD : in front of everything that needed it, but I said we can leave it out, so let's do. Ready to go on to the next? Wave your hand if not. Which two-character symbol begins a single line comment? That's the wrong answer, you Python guys. What's the right answer? Slash, slash. What symbol always begins a preprocessor directive? Hash, shift 3, £. We've only seen 2 preprocessor commands so far, and we've only seen one that we've used a lot, £, include. The other that we saw like on day 2 was £, define. If you say £, include as your answer there, I might give you partial credit, but I would explain to you that no, that's not the symbol. That's the symbol. All right, how about modulus? Yep, %. What will the above code print? Do not copy and paste. I'm surprised I didn't make that a graphic so that you can't copy and paste it. We just have to figure it out. But if we eyeball it, it only wants to know what X is. So honestly, we don't need to figure out what Y and Z is. We can just zero in on what X is. What is X? A plus B. What is A? It's 5 and 3. So what is X? 8. So it's going to print out 8. Now the next one's not going to ask for X. It's probably going to ask for Y. So we can ignore that one, since this one doesn't have anything to do with X. We can ignore that one. We just need to solve that one. What's A divided by 3? They are both integers, which means something special happens. It means it gets truncated, it gets rounded down, it gets turned into an integer. So A divided by B, what's 5 divided by 3 rounded down? 1. Yep. And how about that one? A %B. Well, 3 goes into 5 one time with a % means modulus, which means remainder. 3 goes into 5 one time with a remainder of 2. Everybody remember that, I hope. Didn't mean to close my window. Come back. All right. What keyword is used to mark a variable as a constant? And it's not final, that's for the Java guys. const. You always wonder why the inventors of the C programming language thought that they really needed to save 3 bytes by not actually spelling out the whole word. I don't know. I guess then, though, you get into the idea that int may have been spelled, you know, integer. But in one place in the language, they named something creat. And then that guy got kind of ridiculed later, you know, during a conference or something for not going ahead and using the extra letter to make the word create. Okay, so anyways, const. Alrighty, what data type would be most appropriate for a counter that uses 1 to 10 all whole numbers? Well, if it's whole numbers, we don't need a floating point type, so that rules out double. Bools are for true falses, so we don't want that. Strings are for stuff that you type in from the keyboard between quotes, so we don't want that. So an integer, out of these choices, the best choice would be an int. Now you could argue that, well, I'd rather use a char, or I'd rather use a short int, or just use int as a default for your integer default data types, unless the number is going to be larger than 2 billion, in which case use a long. Which data type would be best for a name? Somebody can tell me that. String. Yep. Which data type could be used to hold a nice fancy long number like that? I should have used the word long. That makes you think long. That number's got a decimal point, meaning that we should choose not bool, that's true false, not int, that's whole numbers. Double, yeah. And yes, you could use float as well. But I did explain to y'all, did I not, that you can get floating point errors, or you inevitably will get floating point rounding errors, and double is far more precise, so just go for double rather than float. Just as a matter of course. There's almost never a reason to use a float rather than a double. Which data type would be most appropriate to hold a true or a false? Now honestly, you could store a true or false in an int because a true is a 1 and a false is a 0. But we have a data type called bool, so why not use it? There's another example of trying to save space. In Java, it's called Boolean, B-A-N. Why not use the whole word Boolean? I don't know. Here we go. Here's some code, and if you copied and pasted it, you'd get the answer and you wouldn't learn anything from it. Like I said, I'm surprised I didn't make that a picture. Might be a picture on the exam, so don't get used to the idea that you copy-paste code. And if you're having to type code into Visual Studio in order to get your answer, then you're not going to get all the answers, the entire test done. You're going to be going too slow unless you're an incredibly fast typist. What will this print if user enters a 10? Int x is equal to 0. Cout, please enter a number. Let them type it in. So by the time we get here, x is equal to 10. And then we have that conditional operator. Now Zach has no idea what a conditional operator is. Not your fault. You just hadn't seen the lecture yet. This is the conditional operator. So what does that mean? The question mark is a conditional operator, meaning that this part gets done first. It gets evaluated, and if it's true, this gets copied across the equal sign. And if this part is false, this gets copied across the equal sign. So if we're sitting here, and they typed in 10, is 10 less than 0? Nah, 10 is not less than 0. So, which value is it going to be, the first one or the second one? False answers go to the second one, so it's going to copy 1 into y. If this was like x greater than 0, then it would have gone for that one. So which can store, I had an excellent question last night. Which can store the larger number, an int or a float? Ints are 4 bytes. This was the question. Floats are 4 bytes. Why would one hold more than the other? Excellent question, and the answer is because floats support exponents, but at a price. There's a flaw. There's a drawback to having exponents. I'll show you what I did. Probably shouldn't write on this. The glare. If the glare's too much on this, I'll just go over there and write on the side. Let me know if that's the case. Let's say, forgetting about binary and ones and zeros and stuff like that, let's say that our integers can be up to 6 digits long. Like that. So we can store any number between 0, 0, 0, 0, and 99999. We have what you physics and chemistry people would say 6 digits of precision. Right? 1, 3, 9, whatever. 8, 2. 6 digits of precision. That's not how floating points are stored in a computer. Can y'all see this, or is the glare too bad? Thumbs up? Okay. Floating points are stored like this. 3.1 times 10 to the 8. They have, why do I always forget what the first part is called? And then they have an exponent. Mantissa. I believe that's what the thing before the exponent is called. So if you have something like this, 4 times 10 to the 5, you've got a mantissa with a 4. You've got an exponent with a 5. Now, I don't care if you remember the word mantissa. I don't think I'm going to ask you. But you got to see that to hold a floating point number requires two pieces of data. So if we wanted to store this number in floating point format, we have to decide how many bits, how many digits are going to be used for the mantissa, and how many digits are going to be used for the exponent. Let's just chop it in half. All right. Now, 139482 in scientific notation is 1.39482 exponent 1, 2, 3, 4, 5. Now let's copy that into our floating point value. That supports 6 digits, 3 mantissa, 3 exponent. 1, 3, 9. Oh. Well, so much for my 482. Exponent 5, 0, 0, 5. The largest value that could be stored in an int using this system would be something like 999,999, right? Nice big number, almost a million. The largest number that could be stored in a float using this system would be 9.99 exponent 999. That's vastly larger, right? This is something with 999 zeros after it. But it's less precise, right? We only have 3 digits of accuracy rather than 6 digits of accuracy. But which one holds a larger value? Floats hold a larger value. This bit about having to allocate space for both the exponent and the mantissa is why you'd rather use doubles, because that gives you more space, more accuracy, more digits of precision in the floating point part. Also gives you more space in the mantissa, in the exponent. Now it's really stored in binary, and there are more than 6 digits, but it's the same idea. It stores a mantissa and an exponent in base 2 in there, according to an IEEE format, which can store the largest value afloat. Which one of these is limited to 2 billion or less, thereabouts? Well, I can guarantee it's not a double. A double can hold something with an exponent of 308. It can have a number with 308 zeros after it. A float's pretty big too. Yeah, you know the answer. A float can hold something up to 38. Why don't we even take these as notes? So a max of a double is something like exponent 308. The max of a float is something of exponent 38. The max of an int is about 2 billion. If it's unsigned, it's 4 billion, but still. And then the max of a long is a zillion, gazillion, billion, trillion, whatever, right? It's a big number. I'm not going to look it up. It's a big number. It's not this big. It's not as big as a double because it doesn't support exponents. But it's something like 16 digits or 32 digits long. It's pretty big. So according to this, the int is the one that's limited to about 2 billion, especially for whole numbers. If I wanted to be more precise, I would say which data type is limited to whole number values of 2 billion or less, but that's still the only one that fits that. Which of these would you use to hold a floating point number larger than 1e to the 37? Now, for some reason, I said 38, but 37, if it's going to be a large number, well, we're not going to store our numbers in strings. Technically, you could, but you'd have to convert them every time. Floats are smaller. Long ints, well, we would not be able to support a floating point number in a long int. That leaves double. Is that 37 correct? Let me Google that up, and we're going to revise our notepad if that's the case. Largest double C++. No, largest float. Well, we can always ask the computer to tell us. Well, see, there it is, 38, not 37. My test question's wrong. I should modify my test to say the value larger than something to the 38. But still. Okay, I'm going to submit it. Any questions over that material? That was a review of Chapter 2. I'd take it again. Oh man, I only got a 23 out of 25. Well, that's because some of them have to be graded by hand. Either I made a mistake in typing spaces or whatever, or some of them are just marked grade by hand because they're never correct. Right? The auto grader just never gets them correct. So I'd have to go and look. When you see something like that and you see a score, don't immediately take the quiz again. I need to go and grade it by hand so that you get a better grade. I mean, yeah, so I can raise your grade. I need to figure out if there's a way to forbid you from even seeing that score like there was in D2L. Yes, sir.
So if we miss something like based off of maybe like missing a semicolon, should we go back and take it again?
I'll fix that. I'll grade it and revise it, and so you're going to see your score go up pretty soon. Yeah. I'll try to find a way to forbid it from telling you your score until I have graded it, because that's invalid information until, right? It's an indeterminate state. It has not been assigned yet. All right, we're going to need PowerPoint 3. Yeah, don't just immediately retake it, because you could take it a million times and probably not get the 100% because some of the things have to be graded by hand. The CIN object. Well, we've been using it all this time. Guess it's about time we talk about it. That's a standard input object. It requires you to use IOStream. # include IOStream. It pulls input from the keyboard. You use those two double arrows. Now the kind of cool thing, this C++ follows a weird syntax, and you'll never find another programming language unless it's a version of C++ that uses those two arrows in order to get keyboard input. But a cool thing about the way it's set up is that if you open a file, don't type this because this is not good syntax, but fin is equal to open file name, right? You're going to open a file for reading, and you want to get some data. This is how easy it is to get that data from the file. Instead of doing scin to read from the file, you use fin to read from, instead of using cin to read from the keyboard, use fin to read from the file. So in order to modify your program to save to a file or to read from a file, you just open variables. And so if you wanted to save something to your file, right, you're going to save the value of x. If you've opened up your file for writing like that, there you go. You send data to it. So these are called IO streams. The IO stream can be the keyboard, CIN. The IO stream can be the console output, your window on the screen, cout, or it could be files that you're reading from or writing to. An input is stored in one or more variables. More variables? Thought we just storing things into one. Well, let's ask for a value and then let them type in two things. Now here's what we're gonna do. Go down here before your pause command if you have one. Let's declare two variables, fname and lname, for first name and last name. They're going to be strings because the user is going to enter them as text. String fname, comma, lname, semicolon. Let's ask the user to type in a first name followed by a last name. Cout error quote. into your first and last names separated by a space. Now, since that went off the edge of my screen, I'm going to break it up like this. You don't need to do that. You know why I'm breaking it up into 2 lines. Colon, space, end quote, semicolon. Or I've gotten real fond of using the greater than sign to tell them where to type. Yes, sir. I could use ENDL to, it would go to the next line. In this case, I want them to type in their first and last names on the same line. But you're right, I could use a new line there. That'd be totally cool. So \n or ENDL. Now CIN greater than F name greater than L name. The first name, the first thing they type is going to go into F name. The second thing they type is going to go into L name. The third thing they type, well, if they type a third thing in, it's going to get ignored. They better not type in a third thing. And then we could print some message out, right? See out, error, quote, hello, comma, space, end quote, less than, F name, less than. That's enough. ENDL. We don't need to tack on their last name. We know how to do that. And let's run it. All right, enter value for X. Yeah, whatever. Enter your first and last name separated by 3. Now I'm going to make a mistake here. Well, firstly, I'll run it. Jeff Thompson. Hello, Jeff. Okay, great, it worked. I'm going to run it again, and I'm going to goof. What if my name is Madonna, and I insist I don't have a last name? Or Cher, right? Or Bono. You know, all these single name people. Bono, and I hit enter, and it just hangs. It really wants me to type in something else. I get frustrated. I start hitting the enter key. I start hitting tab. Eventually, I'm going to be smart enough to type in something. Believe it or not, I believe his last name of his stage name is Vox. There you go. Finally. Hello, Bono. So there we go. You had to type in 2 things to get it to work. What it does is it so-called tokenizes the input, meaning that it grabs one piece of information and then it waits for the next piece of information. How does it know that a piece of information is ended? It's hit a space or a tab or a new line. And then all other spaces, tabs, or new lines are ignored until they finally type in something else that's a non-white space thing. So when you ask somebody to enter a first and a last 2 values or 3 values or 4 values, it may get to the point where they're sitting there wondering why nothing's happening because they haven't typed enough data. And it's just kind of a side effect of that. Well, let's ask them something else. Let's ask them for their age. See out, less than, quote, what is your age, question mark, space, greater than. I'm going to go ahead and do it that way. End quote, semicolon. I don't have an age variable yet. Maybe I'll just store it in X. Stupid, right? But CIN greater than X. I almost typed the arrows going the wrong way. That's a simple mistake to make, and it's simple to fix because it just won't compile until you fix it, right? If I had those arrows going the wrong way, I'd underline them. I'd go, oh, need to change them. No thought required in fixing them. And then let's see out, arrow, quote, next year you will be end quote, less than, x plus 1, less than, quote, space, years old, backslash n, end quote, semicolon. Now, I'm not quite sure that's going to work. I'm wondering if that plus sign is going to botch it. Let's find out. Names, Joe Bob, what is your age? 67. Next year I'll be 68. Okay, it actually worked. Good deal. Here's a consequence of the way that CIN works, is it buffers your data. What does buffering your data mean? It means that you can type in more data than what is asked for, and it's left there hanging, waiting for the read statements. Kind of like I could make more hamburgers than the first customer in line is asked for. Why would I do that? Because the second customer also wants a burger, and the third one also wants a burger. So, you know, I may buffer the hamburgers. I may make 20 hamburgers in order to handle the people who are coming in line. Same idea. If I run it now, and it says enter a value for X, what if I type this? 10 space, Tony space, start space, he's 45. I have no idea. And I hit enter. It goes ahead and does the whole program, right? Hello, Tony. Next year, you will be 46 years old. All of that data was left buffered, waiting to be read by the program. You just have to kind of realize that. Just kind of keep that in mind. Can you stop the buffering? Yeah, you can do what's known as clearing the input buffer. There's a way to clear the input buffer so that if there was anything waiting to come in, it gets blasted, it's gone, and then the next read statement will wait for the user to type in something. All right, one more thing to note about these things is what if you enter the wrong kind of data? Enter a value for X. Tony Stark. Whoops. X cubed equals 0. Enter your first and last name separated by space. Hello? What is your age? Next year, right. It totally botched the program up because I typed the wrong thing in. Can you fix that? Yeah, it's a little bit of work. We're not going to do it right now. Just know that if you type the wrong things in or you type the wrong kind of data in, at this point, you can be sure that your program's not going to work right. I'm not going to count off for that because none of the code that I've been writing does that any better than what y'all are doing. Eventually, we'll get better at it, but for now, we'll just accept the fact that we need to type in the data as it expects it to be typed in. And if we type ahead, like I did that other time, we better get it exactly right. So CIN does convert data to the type that matches the variable. Since height is an int, it converts it to an int. Java doesn't work that way. In Java, you have to specify whether the data that's coming in is an int or a double or a string or something like that. Python certainly didn't work that way. In Python, everything came in as a string, and it was up to you to convert it to an int or a float. So displaying a prompt, we almost always ask them a question and then let them type in something. That's called the prompt, right? We're prompting them for more information. How tall is the room? Without that, they don't know what to type, right? If the first question here was gone, right? If they didn't see that, if we ran that, don't make this change, I'm going to undo it. Enter a value for X. Well, nope, it didn't say that. It's just sitting there. What am I supposed to do? Help, computer. Okay, finally, we may take a guess, but okay. So you always want to prompt the user. You always want to display, tell them what they're supposed to type in. If you write a program that doesn't have the prompt and I don't know what I'm supposed to type in, even if the rest of it's right, I'm going to ask you to revise it to get full credit. Right? You'll get a lot of credit for it maybe, but not full credit because I didn't know what to type. I'd open up the code to see what I was supposed to type. So CIN can be used to hold more than one value. CIN height width, the first thing they type in gets stored in a height. The second thing they type in gets loaded into width. Multiple values must be separated into spaces. You lied. You lied. We've seen that you can also separate them by hitting the enter key, right? Order is important, or the tab key. The first value goes into the first variable and so on. Mathematical expressions. Mathematical expressions, complex expressions can be created by using your operators. Addition, subtraction, multiplication, division, modulus, stuff like that. So this is an expression. Right? Technically, even this is an expression. The number 2 all by itself is an expression. But the way we think of it is that an expression is a series of things with operators, right? Because 2 is just a number, right? There's nothing to calculate. At least the way I think of it, an expression is something that has to be calculated. Here, this has to be calculated. So an expression can be a literal, like that 2. It can be a variable, or it can be a mathematical combination of all of that stuff and operators. That's normally how I think of it. An expression is a series of operators and values and operands. They can be used in assignment, cout, or in any other kind of statement, right? That just gets done first, and then it gets assigned in the area. This gets done first, and then it gets passed into the stream insertion to be displayed on screen. Order of operations. In an expression with more than one operator, unary negation happens left to right. Okay, there's our good old unary operator again, but I don't see a unary operator here, so forget that. And then it looks like everything happens left to right. Multiplication and division happen left to right, and addition and subtraction happen left to right. But that's ignoring order of operations. Right. This is order of operations here. All unary negations happen first, right? All those -1s and -2s and stuff like that happen first. And I don't really even care about unary negation. There we go. I like that better. We have to do the multiplication and division before we do addition and subtraction. Have we done the PIMDAS lecture yet? I know you did it in other earlier classes. Have we done it in this? Is this looking familiar or not? Okay, okay. Yeah. Okay, okay. Order, priority of the symbols. Now that's not the correct term for it, but I like it. Priority. It's really known as precedence or order of, can I spell? Order of operations. If you have this expression, A is equal to 2 plus 3 times 4. From your math classes, you probably know which thing has to be done first, right? Or even if you don't know in math, somebody who's taken another programming class and knows, tell me. You do the multiplication or the addition first? You do multiplication. So you would have to multiply 3 by 4 before you could add it to 2. Why? Because the order of operations. The order of operations is this. Parentheses, first, highest priority. Exponents are next, but our language doesn't support exponents, so we're going to leave that out. Pity. I wish I could do that, right? 3 caret 2 to square it, or I wish I could do the Python operator, but there's just no exponents, so we can't do that. And then multiplication and division are the next in priority. They're the next in precedence. So I'm going to say that that's MD. And then addition and, wait. Multiplication and division, not multiplication and subtraction. My finger slipped, fat fingered it. All right. And then plus and minus, addition and subtraction are the lowest priority. So that means that if we have an expression like this, and so PIMDAS, that's because if there was an exponent one, right, I'm going to delete that because there's not. Somebody came up with a mnemonic, please excuse my dear Aunt Sally. I didn't make it up. It's silly, but just like every good boy does fine or deserves favor if you're a musician and you're learning, you know, little things that help memorize. Please excuse my dear Aunt Sally. But it's PIMDAS. within a priority, you just do it left to right. It's not like you have to do all additions before you do subtractions. You just do them left to right within a certain priority, but you got to do the higher priority ones. And when I say you gotta, the computer's gonna do the higher priority ones, the higher precedence before the lower precedence. So if you do this, A equals 2 minus 3 times 4 plus 5. Okay. The first thing that's going to happen is a multiplication. There's no parentheses to worry about, so that's the first thing that's going to happen. So that becomes 12. Then what's the first thing that's going to happen? AS. That means I better do all the A's first. I better add 17 to it. Now in this case, that would be a really bad thing to do, because then we would be trying to subtract 17 from 2. Well, we don't want to subtract 17 from 2. Instead, everything on the same priority level just happens left to right. So we start at the left. 2 minus 12, well, that's minus 10. Plus 5 is minus 5. So that's what that that's what that expression evaluates to be. And if we put parentheses in there to modify the behavior, like this, A is equal to parentheses 2 minus 3 in parentheses times 4. Why don't I make it positive numbers? I don't like negative numbers. 4 minus 3, right? Okay. So now what happens first? Not the multiplication, the stuff inside the parentheses. So 4 minus 3 is 1 times 4. So A is equal to 1 times 4. A is equal to 4. That's order of operation. That's precedence. Modulus falls into the multiplication division category. But, you know, junior high school people who had to memorize, please excuse my dear Aunt Sally, they didn't have a modulus character, so they didn't call it, please excuse my dear MDM right now. Anyways, you just know if that modulus is addition and subtraction. I'm just going to remove it. I hope you remember that modulus. Maybe I could do all this also modulus. Now, order of operations, there are a heck of a lot of symbols in C++. Not just these, right? There are dots. There are arrows. I'm not going to, don't necessarily type these. I'm just giving examples. There are parentheses. There are those guys. There are, I don't know how many different symbols there are. Well, we're going to find out. We're going to look up precedence C++, find a list, and it's going to be a lot bigger than just PIMDAS. Hoo boy! Highest precedence of all is the colons. That's the very first thing that gets resolved in an expression. So like if you have std : C out, that's the very first thing. And then minus, minus, and plus, plus get done. And there's something wrong with the way that's stated, but that's okay. Not only are parentheses done first, but, you know, square braces are done first. Finally, we get to the point where addition, multiplication, division, and modulus, and then addition and subtraction, right? They're kind of tucked away in the middle of the precedence chart. It's just enough for us to know now. Multiply before add. Get rid of that. All righty. Eyeball this in your head. What's the answer to that? I should pick people. I should put you on the spot. But somebody tell me what this is. Yeah, 2 times 4 is 8. Plus 5 is 13. How about that one? Somebody else. It's going to be a long day. That expression right here, what gets done first, division or subtraction? Speak up, I'm deaf.
Division.
Division, okay, and so 10 divided by 2 is 5, minus 3 is 2. How about this one? We know that multiplication happens first. That's getting to the point where it's kind of long in my head to solve in my head. But anyways, 12 times 2 is 24. 8 plus 24 is 32. No, it's not. Yeah, it is. Minus 4 is 28. Maybe I got that right. 17 modulus 2. Somebody tell me what 17 modulus 2 is. 1. So 4 plus 1 is 5. Minus 1 is back to 4. We get the idea. There's no parentheses in here to make it more complex, but you would know how to handle those. So you can use parentheses to override the order of operations, and you don't even have to use them to override. You're just free to use them when you wanna. If you think it makes the expression easier to read, right? What if I didn't trust that the accountants reading my code would know that multiplication happens first? I could do that, and it doesn't change to the computer the way it behaves, but it might make it easier to read. So feel free to use parentheses if you think it makes it easier to read. Or if you're not sure of the order of precedence. You saw that great big chart I had there, right? 14 different levels of priority or whatever it was. Feel free to use parentheses, even if, strictly speaking, they might not be required. Sometimes they are. Right? If you have this expression, A equals 2x over 1 plus b, for whatever purposes. That's not a real formula. All right, I'm going to write this down. A equals 2x divided by 1 plus b. Semicolon. We're writing it in C. Is this going to work? There's several mistakes. There's at least 2 mistakes. Is this a good line of code? Yeah, the way I'm wording the question, you know, you're pretty safe in answering no. What's wrong with it? Yep, this is the big problem. Well, it's one of the big problems, is that you want this to be done before anything else, so you need the parentheses there. This time they're not optional. And also, just because textbooks like to leave out multiplication symbols, programming languages don't get to. So, if you typed in 2x slash 1 plus b, you'd get lots of credit. You wouldn't get full credit. It wouldn't run. You got to put the asterisk there. The art of taking a formula, a textbook formula, and turning it into a computer expression is called composition. I took this formula and I used composition to turn it into computerese programming expression. I think it's belaboring it to do more examples. What do we do first? We do the parentheses first. 6 minus 2 is 4. Then we have to do what? Multiplication. 12 times 4 is 48. I should give you all a worksheet to work your way through these. I'm sure that there are some in the quiz, though. That's good enough. So multiplication always require an operator. In textbooks or online, you'll see area equals LW. Well, we can't get away with doing that. We have to say area is equal to L times W. And there's no exponent in this language. I wish there was. So if the equation is area equals S squared, you could do area equals S star S, or you could use area equals POW S comma 2. Either one's fine. Now just for squaring something, S times S is fine, but if you're going to take something to the 9th power, S times S times S times S times S, that's kind of ridiculous. Use the POW function. Parentheses may be needed to maintain order of operations. For example, if we're going to type this in as an expression, we darn well better put the parentheses around both the top, the numerator, and the denominator. 4xy better be expressed as 4 star x star y. Parentheses 3, parentheses 12 had better be written 3 times 12. 6b had better be written as 6 times b. When you mix apples with oranges, type conversion.
How would you do like subscripts, like y2 minus y1?
You would just have to name your variables in some way that makes you think of a subscript. Because there's no way, very good question, but is there a way to type a subscript into my language, right? And so if I'm going to do x2 minus y1, int x2 equals 3, int y1 equals 4, int z is equal to x2 minus y1. That makes sense. You're just picking the variable names because there's no way to do a subscript. Okay, now that I've said that, there is a definite meaning to the term subscript in these languages. And if I say x subscript 2, I'm supposed to be doing that. And if I say y subscript 1, I'm supposed to be doing that. That's called addressing elements in an array. Or if you took fundamentals, you called it a list. But anyways, x square bracket 2 in square bracket and y square bracket 1 in sub square bracket. If you were reading this out loud, you would say x subscript 2 minus y subscript 1. Is that the same as this? No, because you'd better have created an array that has at least 3 elements calling the array x, and you better have created an array with at least 2 elements called y. We're not ready to talk about arrays yet. But for what you were saying, if I understood your question correctly, you would do it like this. But I'm not going to use the term subscripts again until we start talking about arrays. Type conversion. Operations are performed between operands of the same type. If they are not of the same type, C++ will convert one type to the type of the other. If it can. If it can't, it's going to be an error. What do I mean by that? What if you do this? Float f equals 3. Int I equals 4. C out arrow arrow f star I arrow arrow India. All right. It looks good. It just works. Underneath it, we kind of need to be aware of what's really going on. Here's a binary operator. It's got 2 operands, one called f, one called I. They are not of the same data type. Mathematically, the computer cannot add pieces of data of different data types. They have to be of the same data type before the addition can happen. So one of them has to be converted to be the same type as the other one. What if this float actually was, had a decimal point? Otherwise, why store it in a float? So we have a 3.1 and a 4. They need to be converted to the same data type before that asterisk can happen. We don't do that conversion. The computer just does it on the fly. The language sets it up on the fly so that we don't have to think about it. But it is happening. Now, are they both being turned into ints first? That would be a bad idea. Because what happens to 3.1 when it gets turned to an int? Rounds it down. So then it would be 3 times 4, 12, which is not the result of 3.1 times 4. So the less complicated data type, the less accurate data type, the smaller data type has to be upgraded to the larger data type. 3.1 would not be rounded down to do an int in order to do this math. Instead, I, the integer, would be upgraded to be a float. So then it would be 3.1 times 4.0, which I guess is 12.4 in my head. Maybe I calculated that right. So that's called implicit type conversion. Implicit means the compiler figures out what's going to happen. We don't sweat it. We hope that the computer gets it right. What if we absolutely wanted f to have been converted to an int, though? We could force the issue. We could do that. Yo, I really wanted f to be an int. This is explicit type conversion. I took f and this is called casting. I cast it to be an int. And now it's going to be 3 times 4, right? Because when you take something that's got a decimal point and you turn it into an int, it loses a decimal point. Now it's 3 times 4. So this is actually a different equation now than it was. We cast it. What does cast mean? Well, I guess it means throw. But the way I think of it as, you know, you take some wax and you cast it into the shape of a candle. You're changing the shape of the wax. Well, we're changing the shape of the data, right? We're turning the metal into a statue or something. We're turning the float into an int. That's explicit data conversion. Implicit is when that conversion happens automatically because the operands are not of the same type. Here's another example of when explicit conversion, implicit conversion will happen. We haven't even talked about functions yet, so this may not make a lot of sense, but I'm going to write it anyways. Okay. If we'd actually typed this into our code and run it, it would have printed 6. It would have been a syntax error in many languages. C is a little bit more loosey-goosey. What Java would have done is it would have done a little bit of type searching and said, 3.1 ain't going to go into an X, into an int. That's an error. I'm not going to compile. Why won't it go into an int? Because it doesn't fit, right? It's got a floating point. What's supposed to happen at that point 1? So in Java, you better tell it what happens at that point 1. You better do some explicit conversion. You might want to do int parentheses around it or something like that to get it to work. However, C++ will say, oh, that needed to be an int? Okay, no problem. I'm going to make it an int for you. And it loses the point 1. So 3, now it's equal to a 3. And returns 2 times 3, and so 6 gets returned, and that's what it prints out. You know what, I wonder if this will really work. Let's go ahead and put this into the code to prove that it works. I'm going to scroll up here to the top. Above main, I'm going to define a function called times2. Oh, did I use Python? Did I put the keyword def there? No, good, I didn't. Alrighty. So int times2 parentheses int x end parentheses. This is how you define a module in this language. In the logic textbook, it was called a module. Here, and in every other programming language, it's called a function. Or it's called a method if you're writing classes. Return 2 asterisk x semicolon. Now let's call our function. Cout arrow arrow times2 parentheses 3.1 in parentheses arrow arrow endl. Let's see if it compiles. Let's see if it gives us a warning that that data is going to be lost. Nope, it just printed out 6. Maybe there was a warning. If I go and find my warning list somewhere, view, error list, 1 warning. It gave me a warning. It sure did categorize it as a pretty low priority warning. Anything that starts with a 4,000 is like pretty low on the list. The higher the number, the more urgent the warning is to deal with. That could be serious business, right? Maybe that point 1 is real important to me, in which case I should have written this to accept a floating point number, like a double. If I wanted to change this to work where it did not round it automatically, where it did not do implicit casting, I should make the function accept a double. You could also make it a float, but I've already said just use double as a matter of course. Don't even put 2 seconds thought into it. Have it. If you start typing a word float, backspace over it and put double. Now it'll work. Now it'll print out 6.2. So enter a value for x. well, I'm not going to keep running it, but 6.2, we saw that it worked. We could do some implicit typecasting. If we really had wanted that to be an int, you know, this is one way, int parentheses 3.1 in parentheses. That's the way that the Python programmers learned to do it. C programmers learned how to do it like this. They put the data type here in parentheses in front of it. Now it looks weird stuck inside the middle of a function call. But let's give some examples of doing explicit conversion using the 3 different ways that C++ supports. And this is going to look alien. The first way, the int parentheses x, is going to look good. Okay, so let's declare some variables. We need a double, I'm going to just call it dd, is equal to 3.1. By the way, I'm going to delete that int there because we're going to wind up doing this ourselves. And then int ii, semicolon. 3 ways of converting that 3.1 into an int. ii equals int parentheses dd in parentheses, that converts it. And why are there so many ways of converting it? Well, one was borrowed from the C language, and one was borrowed from another language, and then one was implemented as something new in C++. Okay, that's like the Python way. Here's the C way. ii is equal to parentheses int in parentheses dd. Now that looks weird, but that's the way C did it, so that's the way I learned how to do it. So you'll see me giving you a lot of examples. Whenever I need to do casting, I will probably do it that way. Why don't we even make a note? We are going to demonstrate explicit conversions, also known as casting. Cast the double to an int. That's what we're doing here. Those are 2 different ways of doing the cast. There's one more way that looks weird. ii equals, now I'm sorry for this bad syntax, static underscore cast, C-A-S-T, less than, int greater than, parentheses, ii in parentheses, semicolon. All right. Maybe you can see why I like the other 2 ways better than this way. You could Google up why use static cast in C++ and learn some reasons why you might use it. There's even a 4th one called dynamic cast. C++ is kind of a big unruly language. And sometimes we see something and we don't dig deeply enough into it. You can Google it. Google why use static cast. I'm not going to ask you a question on an exam, but just for your own education. If you really want to confuse yourself, Google static cast versus dynamic cast. Okay. All 3 of these things do the same thing. I guess this is probably how we ought to do it because it's the C++ way and the other ways are like the C way or the Python way. But they all 3 work, so just pick a way that you like. I'm old school, I do it like that. We haven't learned, I mean, we've learned a lot, but I'm not feeling like we've learned enough to create a new assignment yet. Maybe we have. I don't know. We'll figure it out when we get towards the end of the class. So when data is converted, lower category, lower types are converted to upper types because if you went the other way, you can have data loss. Right? If you have a long, it's not going to be able to be stored into an int. Or yeah, it could be, but you're going to lose some data. We've already talked about an int being a max of 2 billion, whereas a long can hold 2 gazillion. What if you have the number 9 trillion in a long, and then it tries to be implicitly cast to an int? it would lose some data, right? 9 billion cannot fit into an int. We can prove that to ourselves. Let's go and store the value 9 trillion into a variable, right? Double space debt equals 24 trillion. So 24 e to the 12. Now let's put that into an int. No, not an int. Yeah, let's try to turn it into an int. Let's see what it'd look like. So int ID, the integer version of the debt, equals int parentheses, or parentheses int in parentheses, debt. Now let's print that out. Cout arrow arrow quote ID equals space end quote arrow arrow ID arrow arrow ENDL. It's not going to look good at all. Certainly not going to print out 24 trillion. All right, there's our national debt, negative 2 billion. Well, we had data loss. We had data overflow. It overflowed the ability to be held in 4 bytes because we were trying to convert an 8-byte floating point type to fit into a 4-byte integer. We were trying to go down the hierarchy list. If you go down the hierarchy list, you suffer the threat of data loss. So the conversions that will happen automatically go up the hierarchy. Right? Ints can be turned into unsigned ints. Yeah, you'll lose the minus sign though. Ints can be turned into longs with no threat at all. Floats can be turned into doubles with no threat at all. So conversions happen going, implicit conversions, the conversions that C provides for you without doing the casting, go up the hierarchy when they have to be changed from one data type to another. Type coercion is automatic conversion of an operand to another type. I was just calling that implicit. I forgot that this textbook called it coercion. That automatic, what I was calling implicit conversion, is called type coercion. Type coercion. I can't keep that spelling right in my head and long enough to actually get it in. Okay, 2 C's. Type coercion equals when one operand is promoted to be the same type as another operand. Yes, bless you. This happens when a binary operator has 2 operands that are not of the same type. The lesser data type, the lower hierarchy data type, I'm just going to call it lesser, data type is promoted to the higher data type. Ints are promoted to longs, right? Or promoted to doubles. Floats are promoted to doubles. If one is an int and the other is a double, then the int will be changed to a double so that it can multiply the 2 doubles together. I'm going to go ahead and put the parentheses, the term I was using, implicit casting, in parentheses. Now they're going to be talking about demoting as well. Demoting happens if you're trying to store the result of an expression in a variable of a lesser type. Just like when we stored 24 trillion into an int, it got demoted. Now I did an explicit conversion just to prove what I was doing, right? I went into my code and I had this, but even if I didn't have that, in Java that would have been required. Java will never demote your data unless you tell it to. But C doesn't care, it'll do it, it'll demote that data, but when it prints out the debt, it's going to print it out as a negative 2 billion rather than the 24 trillion. So demotion is when you have a value, but it's being stored in a variable of a lesser data type. Everything is always promoted if it's coercion, when two operands needed to be converted to the same type, but then the result might be demoted in order to store into an int. Okay, now that's starting to sound a little bit much, but I've already mentioned integer division and why it can be a risk. The surface area of a sphere is equal to 4/3 times pi times r cubed. However, now that I've typed that, it's not going to work because 4 divided by 3 is 1. Sounds stupid, but they're both integers, and so it rounds down. So you better make one of those or both of those floating points like that, or you could use some explicit casting. You could say, okay, float 4 divided by 3. As long as one of them is a floating point number, it'll work. Now, I'd rather just do 4.0 rather than 4.0 over 3. That's the only way it's going to work. Otherwise, we're going to get the wrong answer. And if the equation was 3 over 4 times pi, well, 3 over 4 is 0. Sounds stupid, but integer division rounds down. So you better make it 3.0 divided by 4.0. So that's demotion. Demotion is when something gets converted to a lower type. So characters, shorts, unsigned shorts are automatically promoted to int. That's a safe conversion. It's fine. Well, not necessarily. Yeah. Anything that these pieces of data can hold can be stored into an int, no problem. If there are different data types, the lower hierarchy is promoted to the hierarchy. It's promoted. When using the equal sign, the type of the expression on the left will be converted to the one on the right. If it says x equals y, then whatever y is, if it has to be converted, it'll be either promoted or demoted according to, with the data types. Whew, we're done talking about that. Overflow and underflow. I showed you all the Pac-Man error screen, right? Yeah, okay. Overflow is when data gets too large to be held in a variable. If an integer can hold 2 billion, but you add another million to it, another billion to it, and it gets too large, it's messed up. It will no longer be a positive number. We're going to prove that to ourselves in our code. Right? Int salary equals 2 billion to 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going to get a raise. Salary plus equals 1 billion. 1 followed by 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's see out our salary. See out, arrow, arrow, quote, salary is, salary space is, space, end quote, arrow, arrow, salary, arrow, arrow, ENDL. And again, it's going to show a negative number. There we go. Suddenly we're earning a negative $1.2 billion because it got too large. Why are we getting overflow? What does that exactly mean? Why is it flipping negative? Because the first bit in signed data is dedicated to indicating whether the number is positive or negative. Let's pretend that we only have 4 bits to hold our data. Well, we could have 0, 0, 0, 0, all the way up to 1, 1, 1, 1. Well, that's not strictly true, because the first bit is reserved to indicate that it's negative or positive. Why? Because what if we had the number -9? That negative is not a digit. If you count out on your fingers, there's no finger that indicates that means negative. It's a symbol that indicates that the value that follows is negative. Well, this first bit, if that first bit is a 1, it means that the rest of it's negative. Now, you mentioned 2's complement. I'm not going to explain what 2's complement is, but I'll mention it in a minute. Okay, so really, we only have 3 bits to play with, because the first one's reserved for either the plus or the minus sign. A 0 if it's positive, a 1 if it's negative. So we can count 0, 0, 0, 0, 0, 1, 0, 1, 0. Have I done the binary card yet where we're counting from 0 to 1 in this class? Is this looking familiar or not? Okay, well, we'll do it in a minute. Finally, you get to 1, 1, 1. I better do that lecture. That'll be next time. This is equal to 7 for reasons I'm not going to explain. And if we added 1 more to it, it would look like that, just like an odometer rolling over, right? If you have an odometer sitting at 999 and you drive 1 more mile, it becomes 1,000. Well, we added 1 more to it. That became 1000. It should have been an 8, but the first bit makes it negative. The next 3 digits, whatever it becomes, according to 2's complement, be -8, I believe. But anyways, it's suddenly a minus sign. The data got too large to hold in the bits that were allocated for it. It overflowed into that next bit, that positive negative bit, and so the data flipped into being negative. Just like your spaceship in asteroids can fly off the screen, right? It hit the side of the screen and it wraps around to come back in on the small side of the screen. Well, that was okay. I mean, the left side of the screen, it's okay. It was programmed to do that. We usually don't want data overflow. We usually don't want our numbers suddenly flipping like that. We should have used a larger data type. Float would have worked, although I've said never use float, use double. Long would have worked if they're all going to be whole numbers. Double would have worked. Excuse me, long.
Did you say salary was supposed to end up being negative?
Did it not?
Or it's supposed to be positive?
Yeah, there it is. It's negative because it went over 2 billion.
Okay, mine's coming up something.
Oh, cool. Let me come look. All right. So we need to be shifting gear towards something that would let us do some homework rather than just this pure abstract conversion stuff. We're going to write a program that asks for the length, width, and height. Nah, that's boring. I guess we'll go for it, though. Of a block and calculate the surface area and volume of it. So we're going to need to know the equations for the surface area and volume of a cube. So I may as well go ahead and list them. Volume of a block is length times width times height, and that's an L. Surface area of a block is, I guess I'm going to put V is equal to length times width times height there. And surface area of a block is represented by the expression or the equation A equals, why don't we use a whole word? Volume equals, and then area is equal to 2 times, parentheses, L times W plus L times H plus W times H. I think that's the shortest expression of the surface area of a block. So our homework. This isn't our homework. We're going to write it together. Our task. Ask the user for the length, width, and height of a block and calculate and display the volume and surface area. Now, if we had more time, if we met 3 times a week, what I would do is I would have less typing during 2 of the lectures, and then the 3rd lecture would be a lab time when y'all just did pure programming without me prompting you. We don't meet 3 times a week, so it's been a while since that happened. Okay, so let's write some code that'll do that. Where am I placing this? I'm putting this up at the very top just to make it easy to find. Or you could put it at the very bottom. Or you could even start a new file. Oh, by the way, don't do this. Don't stick more than one main. Right? If this is supposed to be homework 2 or whatever, don't go to an existing project, add a new file, and wind up with 2 things that say main. You'll get an error. For now, just for now, let's say only 1 file per project. Alrighty. I need to ask for the height, the length, width, and height. So I'm going to have 3 pairs of prompts, but let's declare our variable first. Are we just going to use ints or are we going to use doubles? Well, the width might be 1.5, so let's use doubles. Double L, comma, W, comma, H. Or we could use the whole word. The whole word would be better, right? It'd be more readable. But it's seductive to only use single letter variable names when I'm giving out code samples, because then we're not going to have any misspellings. So cout, arrow, arrow, quote, enter the size of the block, period, \n, end quote, semicolon. Cout, arrow, arrow, quote, what is the height, question mark, space, space, greater, end quote, semicolon, and let them type in the height. So cin greater than h. Now do the same thing for the length and the width. So I would just copy and paste. Big fan of copy paste. What is the length? Cin arrow arrow L. And lastly, what is the width? So I'm going to paste one more time. And I think I've said this before, but the way I'm copying and pasting so fast is I move my cursor to the beginning of the line and hold the Shift key and the cursor key to grab stuff, and then hit Control C to copy and Control V to paste. So what is the height? What is the length? What is the width? Cin arrow arrow W. Now let's do our calculations. I need 2 more variables, one to hold the volume and one to hold the surface area. I could have declared them right up here. Maybe I'll go up and change my variable declaration to include and to have those as well. Or maybe I'll tack on a separate line. Double space volume, comma, area, semicolon. Now I could have put them all on the same line, right? I could put every variable on the same line. I mean, on its own line. I could have waited and declared these things right when I needed them down here at the bottom. Some people like to see all the variables declared up near the top of their program. Alrighty, volume equals, now that I've included CMath, can I get the value of pi from CMath, or am I going to use 3.14159? I'm going to Google real quick, CMath pi. We would have to add a # including, excuse me, a use math defines. Let's just use 3.14159. But we defined it as a constant, right? No, I guess that was my last class. Oh, here it is, my math. Yeah, we do have pi as a constant. Let's use it. So volume is equal to, wait, we're not using pi, it's a cube. Forget all that. Length times width times height, or whatever order we want them to be in. Area equals 2 times, and we have 3 expressions to type here. Length times width plus length times height plus width times height. And now we're going to print our answers. See out area, arrow, arrow, less than, quote, volume of block is, end quote, arrow, arrow, volume, arrow, arrow, quote, space, units cubed, backslash n. We're getting all precise and stuff, because the surface area is going to be units squared. Normally I really wouldn't care. I don't know why I'm doing that this time. And then see out, error, error, less than, quote, surface area of block is, space, end quote, less than, area, less than, open quote, units square, or square, backslash n. And let's just throw in a pause here, if you're on the PC. What if we didn't want to put a pause? Oh, I'm sorry, it's supposed to be system pause. I was about to go into digression. I'm not going to go forward to digression. So let's just do system pause, just to stop the game here, right? Ooh, we got some errors here. What did I do wrong? Oh, I was giving examples. Alrighty. When I compiled it, I got an error. I want you to find the error. You'll see an error list. If you don't see an error list, do View, Error List. And you'll see the thing in yellow we're ignoring. The thing in red we're not going to ignore. So double click, not on the part that's underlined, because that'll just take you to a definition of the error, but double click here. And it says double area is a redefinition. That means that variable already exists. So if you get that error, just double click it, find that line and comment it out, or remove the word double, right? I'm just going to comment it out. It wasn't important. Just an example. I better label that. Example of namespace resolution, colon, colon. That's technically what that colon, colon is called. All right, now maybe it'll compile. All right, what's the height of the block? 1. Length, 2. Width, 3. Those answers are correct. Just out of past history, I know that that's correct. All right, I'm going to scroll back up. Keep all that code on the screen, as much of it as I can. Wander around, make sure that y'all don't have syntax errors. Then we're going to cook up a homework assignment based on this idea. Okay, I can't get all the code on the screen unless I pause it. I mean, shrink it a little. That's just about too much. I'm not liking doing it that much. All right. An interest calculator is like if you are, you know, have $1,000 investment and it's earning 2% interest a year and it's compounded 12 times a year. Can't believe I don't have that there. Then there's a formula for calculating that. Now what puzzles me is that I've tried solving that problem using a loop instead. Like if it's compounded 12 times a year, then loop and, you know, and repeat the calculation 12 times. And I never get exactly the right answer. I haven't figured out why. So the compound interest formula is this. So the formula to calculate compound interest is, ta-da, okay, that's a little too large, but okay. Write a program that will ask the user for the principal, which is the starting amount, of the investment, and then ask for the interest rate expressed as a decimal. You better tell them that because they'll type in 10 when it's supposed to be 0.10. And T, which is the number of months. Assume N, which is the number of times compounded. Okay, instead of T being the number of months, we're going to make T is equal to the number of years. And assume that N, number of times to compound, is 12 because we're compounding once a month, since we are calculating monthly interest. And I do upload these assignments, of course. So based on these values, we're going to have P, we're going to have interest rate, which is R. So the interest rate is going to be called R. And the number of years, which is called T. And then assume that N is 12. Based on that, you can calculate A, which is the final amount. Using the formula, calculate A, which is the final amount. Display this. Now, I would prefer for your program to not just say enter P, enter R, enter N. I'd rather it say something like enter the principal. Better yet, enter the principal, parentheses, starting amount. Enter R, parentheses, interest rate as a decimal, right? That kind of stuff. And then at the bottom, it should say print the final amount or the amount accumulated or whatever is, rather than just say A equals, or even worse, just printing a number. Now, using this information, you can also calculate the amount of interest earned, right? Which is the ending amount minus the starting amount. You could calculate that. So, it'd also be nice to display the interest earned, which is A minus P. So that's the homework assignment. You're still only asking for 3 values, just that this expression is a little bit more complicated, right? What's the trick here? The trick is that you're going to need the asterisk between the P and the parentheses. And what's another trick? You're going to have to use n times t, and they better be put in parentheses, right? If you don't have n times t put in parentheses, and what's the last trick? You're going to have to use the POW function. If you get stuck on the formula, I think I've said this before, but it's not a math class, and if you have trouble converting a formula into an expression, if you text me, I'll show you the expression. Okay. To convert the formula to an expression, you will need parentheses to group parts together, and the POW function to perform the exponent. Right. All right, that's our homework assignment. Can't believe I didn't already have it written up. I know I have it written up for other classes. And by the way, I know that this program is available for you to Google up and submit, but I also know your current levels of programming, so don't copy a solution from the internet. If you get stuck on the formula, ask me for help. It's always okay to Google, it's just not okay to copy what you see. You can use what you learn to make your own code. Does this make sense, guys? All right. Let's make some drop boxes and call ourselves done. And if we need to hang out for a few minutes afterwards to talk about something, that's totally cool.
So did you assign 2 assignments there? Or just this one?
I think this,
The length with height? Or is that
oh, we've already done the length and height. That's just part of what we're going to upload into the daily Dropbox. I phrased it like a homework assignment, but it's not, because we've already done it.